Okay, class, so today we're going to work on some right triangle applications. So here we are, we're at a point right here that's 100 feet in front of the public library. So from here all the way to this public library, this white box, this distance here is our 100 feet. And we're given the angle of elevation to the base of the flagpole and to the top of the flagpole, 28 degrees and 39 degrees, 45 minutes respectively. So the angle of elevation is always going to go to the ground upwards. It's always going to be how we define our angle of elevation. So we have our flagpole here highlighted in yellow that sits on the front of the library's roof. So at the base of the flagpole down here to this spot, the angle of elevation is this one going up to this line that goes up to the base. So that's our 28-degree angle of elevation. And the angle of elevation to the top of the flagpole is this 39 degrees, 45-minute one. Okay, so I have two angles, and I'm labeling my two unknowns. This height here, this height which corresponds to the angle of elevation of 28 degrees, I'm calling x. And then I have my angle of elevation, 39 degrees, 45 minutes. I'm calling that entire height y. So you can see I have this larger green angled triangle and then the smaller purple triangle one. And ultimately what I want to know is the height of the flagpole, which I've highlighted in yellow. So my process is going to be, I'm going to use my purple triangle to find x and my green triangle to find y, and then I'm going to subtract x from y to find the height of the flagpole. So first let's start off with this smaller triangle, which I'm going to pull out. With the 28-degree angle of elevation, I have 100 on my base, and my height of this one is x. So I have an angle, it's opposite and it's adjacent, so I'm going to go ahead and use tangent. SOHCAHTOA, tangent of my angle of 28 degrees is its opposite over its adjacent. TOA, tangent is opposite over adjacent. So I'm just going to go ahead and solve for x by multiplying 100 to the other side. Isolated x, which is the height of the library. 28 degrees is not a unit circle number, so I'm going to use it into the calculator. I'm going to make sure I'm in degree mode. I'm just going to type in 100 tan 28 degrees, and I find that x is approximately 53.17. In our unit, since it was feet here, my x is also going to be in feet. So now I found x. So now what I'm going to do is use my green triangle and go ahead and find y. So they have this bigger 39-degree 45-minute angle with this opposite side y and this adjacent side 100 feet. So I have my bigger triangle. I have 100, and this one is what I'm calling y, and this angle of elevation, which is 39 degrees, 45 minutes. I have an angle. It's a corresponding opposite and adjacent side. So when you have opposite and adjacent, we're going to use TOA, so tangent. So I'm going to say tangent of my angle is opposite over adjacent. Now I'm going to isolate y, so I'm going to multiply 100 to both sides. And so since this right here, which is going to equal y, my angle is not a unit circle angle, so I'm just going to type this directly into the calculator. Remember, you have to go to the angle menu to get your degrees in minutes. And I get that y is approximately 83.17. Again, my units is feet. So that's this entire height from the ground all the way to the top of the flagpole, and we're asked to find just the height of the flagpole. So to find just the height of the flagpole, which I've highlighted in yellow, we're going to subtract y from x, and so it's 83.17 minus 53.17 to give us that it's 30 feet. Since it's a word problem, we always want to answer our word problems with sentences to say that the height of the flagpole is 30 feet. Let's go on to the next problem. This problem, we're going to look at a small plane that is 100 feet high and 1,600 ground feet from its landing runway. The plane descends in a straight line towards the runway. So here we have is the ground, and you have this airplane. There's its propeller up in the sky. And I know that this airplane is 100 feet high. Then it says that it is 1,600 ground feet from this landing runway. So if I call this here the runway, the 1,600 ground feet is this on the ground, this 1,600 feet this direction. So I have these two sides. and it says the plane descends in a straight line. So you have this plane up here, it's going towards the runway in a straight line, forming this triangle. Determine the plane's angle of descent. So in the last problem, we looked at the angle of elevation, which would be from the ground up. So if you're on the runway looking at the plane, this would be your angle of elevation. So the angle of descent would be from the plane's perspective. You're up here in the sky, you draw this line parallel to the ground, and so you're assuming that the plane is originally flying straight, and then it makes this angle of descent down here. So in order to find this angle of descent, there's multiple approaches we can go with it. So one thing is we can label inside this triangle, we can call this angle theta. The advantage here is we know two sides of the triangle, so we can use an inverse trig function to find this angle. And this angle theta and our angle of descent, which I'm going to call star for now, those two are complementary angles, so I know that they sum to be 90 degrees. So if I find theta, I can find my star, my angle of descent, by subtracting from 90. So first I'm going to look at my triangle, and since we know that it's a height, so it's an altitude, it's a right triangle, so I have its opposite and adjacent again. So I'm going to set up a trig function using tangent. So I know tangent of my angle theta, whatever it may be, is opposite over adjacent. So it's 1600 over 100. So this reduces down, if you chop off the 0, to just 16. So in order to find the angle, I'm going to use an inverse trig function, so arctan. So my theta is going to equal arctan 16. And again, this is not a unit circle number, so I'm going to use my calculator. I'm going to use the arctan button, or tan to the -1 button, and I want my theta in degrees, so I'm going to make sure I'm in degree mode still. So this would be the same thing as tangent inverse of 16. So we have that button on our calculator, and we find that theta is 86.42 degrees. Now remember, this is this angle, and I said that those two are complementary. So my angle of descent, which I'm calling star, is going to be 90 degrees minus my 86.42 degrees. I get my angle of descent is 3.58 degrees from subtracting. So again, a sentence answer, the angle of descent for the plane is about 3.6 degrees. Okay, and that is some applications involving angle of elevation and angle of descent.